So welcome back to STARTS Talks in Genova 2020. Now I introduce the next two sessions. We talked before about human, then micro, and now we explore the macro. Sonifying the cosmic signals. The speakers are Stavros Katsanevas and the EGO director, and two artists, Evelina and Dmitry. So I call them on the stage.
Good evening, everyone. So are we live right now?
Please start your presentation.
Thank you very much. Can you share our presentation?
Yes, indeed.
And my name is Evelina Domnitch, and I work together with Dmitry Gelfand. And in 2016, we were invited by curator Isabel Besena to have a residency at LIGO, which is an American gravitational wave detector. It's actually an international project, but we had our residency in Pasadena at Caltech.
We were very fortunate that during the first week of our residency, we were able to attend a lecture by cosmologist and string theorist Juan Maldacena, who proposed his and Leonard Susskind's conjecture ER equals EPR, which proposes that wormholes connecting two sides of the same black hole or two distant black holes might be a macroscopic manifestation of quantum entanglement. At the end of his lecture, Maldacena mentioned that perhaps certain insights could be gained through hydrodynamic analogs of black holes. We found this to be quite comforting because much of our work has to do with fluid dynamics, and essentially black holes have quite a few phenomenological parallels to liquid vortices. When you have a vortex in a liquid, it is a singularity. It is a hole in the liquid phase. And the way that the liquid flows around this singularity is quite similar to the way in which space-time itself is distorted around a black hole.
So we started thinking if we can create a fluid dynamic analogy, not of a single rotating black hole, or let's say the way it distorts with its very strong, very big mass, the way it distorts space-time itself and sends out gravitational waves that are detected by LIGO and Virgo, but whether we can create a fluid dynamic analog of two entangled black holes or two entangled vortices. And here you see a photograph that we took at their swimming pool of Caltech, which we booked for 1 hour of experimentations. And everyone had to leave the swimming pool at this time. And we were creating with very simple means these two co-rotating vortices that, as in this image, you can see by small air bubbles that outline this cord or this bridge that connects these two vortices. In fact, what we observed is if this cord is intact and you don't sever it mechanically, the two vortices will live for quite some time and will drift very peacefully along the swimming pool until they hit the wall of it, or until some other vibrations on the surface of the water will disturb them.
When we finally developed the installation
that you can see on this photograph, exhibited actually in Italy, not that far from Genoa, in Bergamo.
In a place called Gamnec. So what you see essentially begins on one side of the aquarium. A linear actuator displaces a volume of water through a beveled gateway. That is how the vortex, the double vortex, is seated. Excuse me. Okay, hello.
Evelina and Dmitry, we hear you and we see you very well. You probably have another tab open in your browser. And
yes, we're going to try to
close the other tab, not us,
yes,
please.
Sorry about that.
No problem at all. Thank you.
Yeah, so the double vortex is seated on one side of the aquarium by water being displaced, going through a beveled gateway akin to the diffracted passage of light in a double slit experiment. And then the vortex very gradually floats across approximately 1,000 liters of water, and it is illuminated from below by an expanded multicolored laser beam, which transforms the vortex pair into a dynamic lens, upwardly projecting two black holes encircled by shimmering halos, which is quite analogous to the super radiance surrounding in the ergosphere, the area surrounding a black hole. You can see these halos in this close-up.
And of course, I'm sure Stavros in his presentation will tell you all about it, but by the time in 2016 we had our residency at LIGO, there were just a few detections of gravitational waves, and the most amazing thing about it is it's the smallest amplitude vibrations detected, but the frequencies are in the audible spectrum. So there are sounds for our ears, and we got this data from LIGO scientists together with some other very curious recordings of quantum fluctuations inside of the detector, which is a 4-kilometer long, 2-meter in diameter vacuum chamber. And we gave all this material to composer William Basinski, who wrote a score for this work. And since we have so little time for our presentation, I will just put some links where you can listen to this recording later. And I think that we are pretty much done with our time.
Well, if we do have a few, at least another minute or so.
See, you have 2-3 minutes at least.
Oh,
Okay,
okay, brilliant, brilliant. Because I think it's important to note that in the conjecture as well as in the title of the artwork, ER refers to a paper written by Einstein and Rosen, which proposed the existence of wormholes or Einstein-Rosen bridges. And on the other side of the equals sign is EPR, that's stands for Einstein, Podolsky, Rosen, which was a paper from the very same year, penned by Einstein, Podolsky, and Rosen, predicting quantum entanglement, something that Einstein did not actually believe was possible.
And here you're looking at an article from New York Times from the 1930s.
Yes, and as controversial as it was, of course, the quantum revolution took place, and now we are seemingly in the midst of the second quantum revolution, where indeed, finally, it seems, through such a conjecture, the realms of quantum theory and relativity might finally be united. The implications of such a theory are so profound that perhaps the very connectivity of space itself is based on quantum entanglement, on a quantum tensor network. This might further imply that the qubits or quantum bits of information are more fundamental than space-time itself.
So we would like to thank you for your attention, and I think we are done.